All right, this is a video on properties of logarithms, and we'll start off with an introduction going over a summary of the main properties we'll be working with, and then we'll be doing a few solved examples. So the first property we'll look at is called the product property, and we won't really get into a derivation of where these properties come from, but I will try to touch on a little bit of a connection between these properties and analogous exponential properties. But what's most important really is that at this point you simply memorize the properties and are able to apply them. So the product property says that the log of a product of m and n, is equal to the sum of the individual logs of m and n. And that works as long as we're dealing with the same base all the way through, which I'll just refer to as b in this case. Okay? So the base doesn't really matter as long as it's a consistent base all the way through. So this connects a multiplication and an addition in a similar way that if we had something like this, that exponential property that I wrote over on the right-hand side connects a multiplication and an addition. Okay, so they're similar properties. But really what I want you to think about for the log property is that the log of a product is equal to the sum of the separate logs. And just like multiplication and addition are in some way connected through logarithms, division and subtraction are similarly connected through logarithms. So here we have the log of a quotient, the log of m divided by n, is equal to the difference of those two logs. In a similar way that with our exponential properties, we have a connection between division and subtraction. We can subtract the exponents as long as the bases are the same if we're dividing powers. The power property is similar. And it's similar to this property here. If we have b to a power raised to another power, we're allowed to multiply those powers. So similarly with logarithms, if we have a log of a base raised to a power, and here in this case the power is n, we can multiply that n out front. And I like to think of this as being really bringing the n down out front, and it becomes a multiplication. Okay, I want to make a quick caveat. This applies to logarithms. This doesn't apply to general arithmetic, right? So we can't do this. We can't say that m to the n is equal to, we can't bring that n down out front and say that's the same as n times m. That doesn't work. This only applies in the world of logarithms. Okay, that's important. And then lastly, the change of base property is what I honestly think is the most applicable property that we'll be using in this class, and it allows you to literally change the base. Okay, so for example, if you have a logarithm with a base of b, and say that's a base that your calculator can't manage. Okay, calculators can typically manage bases of 10 or bases of e. Say this is some other base. We can change the base to whatever other base we want, as long as the bases are greater than 0 and not equal to 1. And we can make a new base, a base of c, and we can do that by dividing. Okay? And so log base b of m is going to be equivalent to log base c of m divided by log base c of b. And I like to remind myself of the division in the way that here b is a little bit lower than m. It's written as that subscript, right? So here the b is lower than the m in our division. Let's actually apply this a little bit, apply some of these properties, and through some practice problems. So first one, log base 4 of 32 minus log base 4 of 2. Hopefully you can see the bases are the same, and in this case it effectively means that we don't need to worry about the bases right away. We can simply worry about the subtraction, and we can remember that the difference of two logs is the log of a quotient. So this is going to equal log base 4 of 32 over 2, which is log base 4 of 16. And then we can even think about what that means. That really means 4 to what power is 16? Remember, logarithms are equal to exponents. So 4 to what power is equal to the exponent right there? What's the exponent? And 4 to the 2 will be 16. 4 squared is 16. So that would be our solution there to fully simplify it. In some cases, we have a variable in our expression and we can't fully simplify to a particular number, but we can still apply our log properties. So in this next example, we have the sum of two logs, and that's going to equal the log of a product. So this will equal log base 4 of 5x times 3x. And we can keep going with that. That would be log base 4 of 15x squared. We can go in the other direction as well. We can expand, and in this one I'm showing you the log of the quotient of 4x divided by y. And there's no base written, and so I want you to recall that that implies there's a base of 10. That's called the common log. If there's no base written, we're working with a base of 10. So we can remember that the log of a quotient is the difference of two logs. So we can write this as the log of 4x minus the log of y. And we can go one step further. Here we have a log of a product, which is the sum of two logs. So this is log 4 plus log x minus log y would be our final answer right there. We can keep practicing, keep putting more of this together. Here again we have a quotient, and I guess one thing to think about is think about where the implied parentheses are. So here there's some implied parentheses up top and implied parentheses down below, which you don't really need since it's just a 729 down below. But that implies we're doing the division first. There's a big global division that's happening before inside the division we need to think about what's going on inside the parentheses. So let's another way of thinking about that is that logarithm only sees the division right now, okay? It sees the division between two sets of parentheses, an x to the 4th up top and a 729 down below. That exponent of 4 is kind of hidden inside the parentheses. The logarithm doesn't see it yet. We'll worry about that later, okay? So let's go ahead and do that. So we have log base 9 of x to the 4th minus log base 9 of 729. Okay, now we can do a couple things. We can apply our power rule, which means that 4 can come down out front. And we can also think over here, that really means 9 to what power is 729? And that's the power of 3. You might not know that in your head, but you can do 9 times 9 times 9 to get 729. So we can do a little bit of simplifying and turn this into 4 log base 9 of x minus 3. That would be our final answer right there. Change of base is where it gets really, really useful, particularly when you're using a calculator, a scientific calculator. I just have a very basic scientific calculator right here, that's all you really need. And you can do the change of base on it and do some pretty sophisticated math with it. So let me show you how to do this with a calculator and without needing to find a common base or any of our other tricks or methods that we have been using. So when we do the change of base, we can change it into any base we want. So let's choose a base of 10 since our calculator has that button. So this, we can turn it into log base 10 of 27 divided by log base 10 of 81. And just to be clear, 81 and 27 are both powers of 3, so I probably could have turned this into exponential form, gotten common bases, and done this more by hand, but I'm trying to demonstrate the change of base method. We can apply each of these things in our calculator, and we don't even need to think about the fact that it's base 10. We can just write log 27 divided by log 81. By the way, it's useful to think about what the answer might be. Looking at the original problem, that really means 81 to what power is 27? And so I can tell I'm going to have a number less than 1. So hopefully we are going to get a number less than 1. Then we just go to our calculator and do 27 log divided by 81 log and I get a 0.75. We can always check that, and we can do 81 raised to the 0.75, and we do get a 27. And this should work for numbers that are less clean as well. 5 and 36 don't share a common base. But we can also still kind of estimate what we think the answer might be. 5 to what power is 36? It's going to be about 2 point something, maybe 2.5, something like that, 2 point something, because 5 squared is 25 and 5 cubed is 125. So maybe 2.1, 2.2. Let's see. But we can do log base 10 of 36 divided by log base 10 of 5. Go to our calculator to do that. And I get 2.23 when I round to 2 decimal places. And once again, we can do 5 raised to the 2.23 as a check. And we should get about 36. I get 36.199, and that works for me because there was a little rounding involved. So we got through it. Those are our that's our video on properties of logarithms. Hope it all worked out for you, and that's a good place to stop.